This video is on Unit 6, Chapter 12, Exponential and Logarithmic Functions, Lesson number 3, Solving Logarithmic Functions. In your notes here, under logarithmic equations, the first type that we're going to look at is when you have a log on both sides. So log equals a log. There are some steps for us to look at. First, it says condense each log. So you want to make sure that you have one log on each side. If you have multiple, then you have to use the rules that we learned in lesson number 2 to condense. Step number 2, use the one-to-one property. If log base b of m is equal to log base b of n, then we know that m equals n. And basically what I say is you just drop the log parts and set up your equation. Step number 3 says solve and check for extraneous solutions. So any logarithmic equation that we have, anytime it says log, we have to make sure that we check our solutions and make sure that we didn't create an extraneous solution in that process. So looking at example, let's start with example number 1, something very simple. Log base 5 of 5x plus 9 is equal to log base 5 of 6x. What's happening here in that one-to-one property is your logs are basically going to go away, and you've got your 5x plus 9 is equal to 6x, and then we want to solve. Subtract the 5x, and you get x is equal to 9. Now, again, you have to check that, make sure that 9 actually works. To do that, what we're going to do is we are going to substitute the 9 into the left side of the equation and the right side of the equation to make sure that they match. So I'm going to pull up log base 5. 5 times 9 plus 9 gives me that. And then on the right, I'm not sure why that did that twice. On the right side, we've got log base 5 of 6 times 9. And that gives me the same 2.47849, yada, yada, yada. So the left side equals the right side, which means that 9 is my solution. And for time, I may not check every single one. I will just let you know what those solutions are. But that's the process that you need to go through to check for extraneous solutions. Let's jump down to number 4. Notice on number 4, you have 2 logs on the left, 1 log on the right. We need to condense the left side because there's a plus in the middle. We are going to multiply the y plus 5 times the 4. So this is now going to say log of 4y plus 20 is equal to log of 72. And again, now that we have 1 log on both sides, we're just going to get rid of the logs and solve our equation. So I've got 4y plus 20 is equal to 72. Subtract your 20, and we get 52, and then divide by 4, and y equals 13. And again, what you want to do is you want to go to your calculator, plug the 13 into the left side, see what that's equal to, and then find the log of 72. Make sure that the left side really does equal the right side. For time constraints, I'm going to go ahead and tell you that 13 does work. Let's jump down to number 8. Looking at number 8, the right side of the equation is our problem. And what we need to do first is take care of the product, which is the exponent. So that's going to get rid of that 2. I don't want to put an x through that. Let me just change that to that. So the 2 becomes the exponent on the 6. So that's really 36. I got log base 3 of 36 minus log base 3 of 4. And then what I want to do is combine the 2 on the right. Because there's a minus in the middle, we want to divide. 36 divided by 4 is 9. So now this says log base 3 of 9. And now we can get rid of the logs and solve our 2p minus 5 equals 9. We'll add the 5. 9 plus 5 is 14 divided by 2, and we get P equals 7. And again, you would have to substitute that back in to check, make sure that it works, and it does. Let's jump over and look at number 10. Number 10, I've got log of 2 plus log of k squared is equal to log of k squared plus 16. So for this one, we need to condense the left side through multiplication. So we just need to multiply the 2 times the k squared to condense. And then we're going to get rid of the logs. And 2k squared is equal to 16. Sorry, k squared plus 16. And then I'm going to subtract a k squared. And I'm going to use my square root property here. And I get a positive and a negative 4. Now, you want to make sure that when you are using that square root property that you don't forget the positive and the negative. When you substitute in the positive 4, it will work. And when you substitute in the negative 4, it will also work. So we have 2 solutions for number 10. Let's look at the next type of logarithmic functions. So for number 2, it says log equals a number. So basically what's happening here is you have a log on just one side of the equation. The other side is going to be a number. The steps tell us to condense and isolate the logarithms. So again, log equals a number means you can only have one log. You cannot have multiple. You can only have one. Step number 2 says write the equation in exponential form. So we're going to change it from a log form to exponent form. And then in step number 3, it says solve and check for extraneous solutions. So looking at example number, let's look at number 12. Actually, let's not. Let's look at number 11. Number 11 says log base 2 of x minus 4 is equal to 6. So what I want to do here, I have a log equals a number. I'm going to change it to exponent form. So exponent form, the base on the log is the base on my exponent. And then the 6 is your exponent is equal to the x minus 4. And then we just solve and check. 2 to the 6th power is 64. And then we add the 4 and get 68. Again, you must check your answers. So plug the 68 into the parentheses in the x, plug it in the calculator, make sure that the left side and the right side really do equal. And again, for time's sake, I can tell you that that does work. On number 12, the log does need to be by itself. So for number 12, to start that out, you would need to add the 7 to the right side. So log base 3 of 4x plus 8 is equal to negative 3 plus 7 would be a 4. And then we want to change that back, change it into an exponent form. So 3 to the 4th power is equal to the 4x plus 8. 3 to the 4th power is 81. Then we would subtract the 8. 81 minus 8 is going to be 73. And then when we divide by the 4, we get 73 over 4. Now, that will not simplify. That's a very ugly fraction. I grant you that. But when you plug it back in, it will work. All right, so let's jump down to... let's look at number 14. Number 14 says 2 times the log of x minus the log of 4 equals 2. So on the left side, I need to condense. The first thing I need to do is take care of this exponent. So that's really log of x squared minus log of 4. So because there's subtraction, these two logs are going to become 1 through division. And then we want to change this back to exponent form. So the base on this log, because there's not a base, is an understood 10. So 10 squared is equal to the x squared over 4. 10 squared is 100. Multiply both sides by the 4. And we get 400 is equal to x squared. And I would go ahead and square root both sides. You're going to get x equals a positive and a negative 20. Now, when you substitute that back into the original, and you must make sure that you are substituting it back into the original equation, not after you've got it condensed. That's not going to work. You got to go back to the original. The negative 20 is not going to work. So x is only going to be equal to a positive 20. Make sure you go through the steps in your calculator to check that while you're in this video, just to make sure you understand that it truly does not work. And then the last one that I want to do is, let's do number 15. So number 15 says log base 6 of x plus 9 plus log base 6 of x is equal to 2. Again, you've got too many logs on the left, so we're going to condense the 2 into 1. And because there's a plus, we need to multiply those two things together. So it's going to be log base 6 of x times x plus 9 is x squared plus 9x, and that's equal to the 2. Then we're going to change it to exponent form. 6 squared is equal to x squared plus 9x. 6 squared is 36. And then we want to subtract the 36. You want to make sure that you're doing that because you do have a quadratic that you need to solve through factoring or quadratic formula. So I'm going to factor this. Two numbers that multiply to give me 36, that add to give me a positive 9. 12 and negative 3. So a positive 12 and a negative 3. So that tells me that x can be a negative 12 or x can be a positive 3. The negative 12 is not going to work. So again, you would each one start with the negative 12. Let me show you what this might look like. Log base 6 of negative 12 plus 9. And then we need to add another log base 6 of x. And x, again, I'm using the negative 12. So notice that when I'm checking this, I'm going to stick that negative 12 in to both x's. And then when I check it, what's going to happen is we get this I. And that can't happen. So what that means is that the negative 12 does not work and x is only equal to 3. So those are your notes for chapter 12, lesson number 3.